Hello, my name is Patricio Morales Prego, and today I'm presenting study of the structural and electronic properties of yttrium barium copper oxide doped with gadolinium conducting ceramics. Superconductivity is a phenomenon where materials' electrical resistance drops to zero when cooled below a certain temperature, called critical temperature. This temperature is usually around 0 Kelvin. However, in the 80s, a new type of material called high-temperature superconductors were discovered in which this temperature was higher than that, way higher. One of the most promising of these materials was yttrium barium copper oxide, YBCO, which had a Tc of around 90 Kelvin. And as you can see in the figure, if the structure is properly oxygenated, then its crystal structure is orthorhombic and it has a higher Tc than if it were not properly oxygenated and its structure were to be tetragonal. In this current work, what we do is substitute the yttrium atoms with gadolinium, and this has been shown to improve in thin films superconducting properties as well as the critical current it can hold. So to do this, what we did was to synthesize the yttrium barium copper oxide doped with gadolinium polycrystalline samples for the concentrations of 0, 0.05, 0.10, 0.15 using the solid state reaction method. Then we characterized the compounds using a X-ray diffractometer, and we identified the crystalline phases. Later on, the chemical orbitals and valence bands were measured by X-ray photoelectron spectroscopy using an ultra-high vacuum microzone scanning with the specification shown here. And lastly, we characterize the method by its electrical resistivity at low temperature measurements, which were performed using the 4-probe method within a temperature range of 300 Kelvin to 77 Kelvin. These are the results we got. First, these are the diffraction patterns for all the compounds and the concentrations. As you can see here, the compounds did not show too much of chemical impurities. We got pretty much the phase that we wanted to get. And in the inset, you can see that the unit cell volume actually grew with the increase of gadolinium content in its structure, with the exception of 0.05. This volume was calculated using the cell parameters found by doing a Rietveld refinement. Next, we have the XPS survey of the yttrium barium copper oxide doped with gadolinium compounds. Here we can see that we successfully identified the chemical states for each element, as well as the Auger peaks. And lastly, here we have a graph that shows the curves of resistivity at low temperatures for the compounds synthesized. The inset of these graphs shows that the Tc of each compound was increased slightly as a function of the gadolinium content. We can also see as well that all of the compounds showed a true transition into the superconducting state near a critical temperature of around 90 Kelvin. So to sum up, polycrystalline samples of yttrium barium copper oxide doped with gadolinium were synthesized successfully by solid state reaction technique. We also think that the different ionic radii of yttrium and gadolinium were the cause of the increase in the unit cell volume of the compounds found with Rietveld refinement. Later, we saw that the chemical orbitals were identified using XPS successfully. And lastly, the R versus T curves showed the metallic behavior as well as the superconducting transitions successfully, wherein the Tc values were found to increase with the concentration of gadolinium. These are the references used for the work, and we also would like to acknowledge that this work was partially supported by the projects that you can see on screen. That will be all, and thank you for your attention.